Welcome, everybody, to this very first OpenShift Commons briefing of 2016. I'm Diane Muir, and I'm the Community Director for OpenShift, and I'm really pleased to have with us today Pete Muir and a number of his colleagues and friends from the Container Development Kit, or CDK, project, and we've been doing lots of work trying to improve the local container development experience, and they're here to talk through their approach to it and hopefully get your feedback on it. So I'm going to let Pete kick it off, and as people join, they can introduce themselves.
Thank you, Diane. So the agenda for today is I'm going to spend about hopefully 10 to 15, maybe 20 minutes talking through kind of what we see the problem to be, what the goals of the work that we've been doing is, and then kind of give you an idea of, in a little more detail about what we set out to do in order to meet those goals. I'm then going to hand over to a couple of colleagues who are going to give you a demo of what we have so far. So I'll start by introducing myself. So my name's Pete Muir. I work for Red Hat. I'm the engineering manager at Red Hat for developer tools. And with me, we have a number of people from the team, but in particular speaking are going to be Max Anderson, who is the architect and lead for the tools that help people build and deploy applications, and then Fred Bricon, who works on the OpenShift tooling inside of Eclipse. We also have a few other people who I'm sure will be contributing via chat, and perhaps answering some questions at the end. So before we get started, I want to give everybody a sort of, an idea of where we are in this journey. When Diane asked me to do this, she was very clear that, you guys like to hear quite a lot about what's coming up, that, what we show you can be pretty rough and ready. You'd really like to hear kind of an idea of what's coming up. So I'm very much, we're very much here in that vein. We're very much here to say, look, this is kind of what we're working on. I would describe what we have as sort of probably around alpha quality at the moment. We're working hard to move that into beta and beyond, and through to GA. But it is rough around the edges. But the goal is to show you kind of the direction in which we're headed. The team has been doing an amazing job of putting it together. The first time we really managed to get an end-to-end flow on the demo that we're going to show you was a couple of weeks before Christmas, and obviously the team was mostly off over Christmas. So I think we're going in the right direction. We've got really good velocity going in that direction. So like I say, early adopters at the moment, but I definitely encourage people to check it out. So with that, I'll get started. I'll try not to talk too much and for too long, and get on to the meat, which is the demo. So if we could go to slide 2, please. So I wanted to start with a kind of a quick problem statement. We're the developer tools team, so we really care about making development of applications easier. We see containerized applications as probably one of the most important trends in application development in the industry for a very long time. Because of all the well-known benefits of containers, of Docker containers. But we also recognize that this is a new technology, and at times it's been really hard to actually build applications. Many of the kind of conveniences that we're used to when we've built applications to run on bare metal got lost in the containerization effort. So it was pretty hard to get started with at times. And it was also pretty slow. There were some really long turnarounds when you would have to, change your code, test it out, build it into the container, get the container running, and see those changes running. That goes from, so my background is with Java middleware. So something like JBoss App Server, when I'm running on bare metal, I can get a turnaround in 2, 3, 4, 5, 10 seconds with the application restarting. If I'm doing that in a container, that can go up to minutes. We are really concerned about that because we know that the kind of the code debug cycle that people work through needs to be really fast in order for developers to be productive. So the problem we're trying to solve is how can we make it easier to get started with so there's no barriers to entry, and how can we make it really a really good environment for developers to work in. So if we want to go to slide 3, our goals, like I said, pretty simple. It needs to be really simple for the scenarios that we defined, which is kind of this, getting started scenario. We focus very strongly on Java and on JavaScript. Those are our two focus areas, and particularly focusing, I guess, on kind of microservice apps written using Java. Secondly, it's got to be really fast, so it's got to be really fast to write and debug code. So those are just the two goals we were trying to achieve with trying to set out to solve with this work. So if we want to go to slide 5, I now want to talk a little bit more about what we've been working on and kind of who the target audience is and why it might be relevant or why it's relevant to you. One of our guiding principles in the developer tools team is that we're quite opinionated about what we do. So we know that we want to produce a really productive, really good developer experience, but we know that if we try and do that for everyone, that's going to be really hard to achieve. So we try to be really tightly focused on some particular types of users and some particular scenarios to try and really optimize for those. So the scenarios that we wanted to optimize for, in this case, were JavaScript and Java developers who are running Windows on their development machine and are deploying to a Docker-based environment such as OpenShift. And we think OpenShift is definitely the best Docker environment to deploy to, so our focus as the Docker environment was on OpenShift. So that's the target audience, JavaScript and Java developers running Windows on their desktop, deploying to OpenShift in production. So if we go to slide 6, let me start to talk about what you get in the box when you download the work that we've been doing, when you get hold of the work that we've been doing, and you'll see this in the demo in just a few minutes. So in order to, if you remember our first goal was simple. So we wanted to make sure that everything you needed to build your Java application or your JavaScript application was included in the box. And so for us, that meant we included JBoss Developer Studio, our IDE, OpenJDK, in order to be able to run the IDE running on your Windows machine. We included the Container Development Kit, which gives you access to an OpenShift environment that's running on your local machine. We include Vagrant in order to get the CDK up and running, and VirtualBox in order to run the virtual machine that the CDK runs in. This all comes in a single download, a single installer, and it runs, like I said, on Windows. So if we go to slide 7, please. So what scenarios is this optimized for? And this is where we come back to, both of our goals. So it's optimized for running JBoss Developer Studio and OpenJDK running on your Windows laptop, which then communicates with an OpenShift that's running inside a virtual machine, where you can interact with the lifecycle. You can use the source-to-image capabilities, and you can interact also with it using the GUI and the CLI. And then we're looking at applications which are running inside Docker containers, and we were particularly focused on EAP, JBoss EAP applications, and Node.js applications. So if we go to slide 8, please. So why should anyone care about this? And I've kind of talked about this a bit with the goals, but let me just reiterate. We wanted this to be really simple. We wanted this to be as simple as being able to do a Docker run, CentOS Wildfly. So we wanted this to be a single installer, a single downloadable that you could get hold of. And then once you've got it, we want to offer you the ability to really quickly deploy your code and really quickly debug your code when it's running inside that Docker container. So what was our kind of, our conceptual journey? How do we think, what do we think the steps that you needed to take in order to get started should be? And then you can judge us when we do the demo on how well you think we've attained them. So if we go to slide 10, please. So we assume that you were starting with pretty much a bare metal machine. So your first step is to install Windows, and our target really is Windows 7, 8, or 10 running on your laptop. If we can go to slide 11, please. The next step you need is to get a redhat.com account, and you need to be able to sign up for the $0 developer subscription. And this $0 developer subscription is totally free to anybody who wants to use our software for development. And the subscription will contain the CDK, it will contain Atomic Host, it will contain OpenShift Enterprise and JBoss Developer Studio, all the components you need to get started. This subscription isn't quite launched yet, which is going to make it somewhat hard to use right today, but like I said, we're working on all of these items and getting all of these done. So if we go to slide slide 12, please. So having got your redhat.com account, the next thing you need to do is download and run the installer. So the installer will install the components we've talked about in the box, so JDK, the Container Development Kit, Dev Studio, and OpenShift Enterprise. If you go to slide 13, the installer will then also ask you to enter your redhat.com credentials so that you can then update and run any updates and install any additional software that you need into the environment. Go to slide 14, please. The next step you need to do is to be able to start your development environment, run JBoss Developer Studio. Slide 15, please. And then, obviously, you want to be able to use a sample application. So you have the ability to select from some common applications, some common sample applications inside JBoss Developer Studio. And this should run straight away in the local OpenShift environment that you're using without any additional setup. And finally, of course, we want you to be able to change code and see those changes reflected quickly in your running application. So that was our goal. That was the kind of really what we set out to do, a really simple, easy to get started experience, and then be able to see those fast code changes. So with that, I'm going to hand over to Max and Fred, who are going to take you through the demo and show you some of the, show you how we've worked towards some of these goals and see how much easier I think we've made it in order to get started with this local container developer experience. Max.
Hi, thank you, Pete. So this is Max Anderson. As Pete said, I'm the architect behind the deployment and coding in our developer experience. In the past, I've been leading the Developer Studio work. So if you've seen me talk about Eclipse plugins, that's what I'm doing the last few years. But now we're going into more Eclipse tooling and beyond for this container tooling. So I'll show the installer. Yes?
We can't see any screen. No one's showing it. At least a bunch of us can't actually.
Make sure I'm share again.
Yeah, there you're
back.
We're receiving your presentation slides, but not your desktop.
Okay, but I'll come to that in 2 seconds. Okay.
Diane, we're not seeing the slides though either.
A
bunch of us aren't seeing the slides. Are we in? Is it supposed to be in Blue Jeans?
It's in Blue
Jeans.
Yes.
Blue Jeans. Right now there should be a video because I'm installed.
No, like Mark Borstein, myself, and Xavier. None of us see anything.
Okay, let me.
The presentation is going out.
Yeah, the presentation is going out.
It is? I haven't seen it.
I mean, I see the video.
Yeah.
I haven't seen anything.
Okay, as far as I can see, people saying they can see it. Okay. You are the unlucky one, it looks like.
Yeah, there's some of us that are unlucky. So just make sure that it's being recorded, and I guess we'll watch it later. Maybe it'll be available then.
Yeah.
Okay, cool. Sorry for that. But anyway, I'll show the installer, then I'll hand over to Fred for doing the tooling workflow, and will come back to me. I'll summarize what was shown and some of the things that we couldn't fit into the demo or we haven't polished enough to show off yet. So again, the idea here, what you're seeing here, I'm showing a video of the installer because actually running the installer takes a bit of time because it's a rather big download. I'll walk you through. So first of all, when you have the installer, you'll have to log in with your username and password for the developer Red Hat developer account. And this is purely just to get access to the productized binaries like OpenShift Enterprise, the CDK that has a Docker and Atomic in it, and JBoss Developer Studio in there. So once you've logged in, it will, of course, verify. If you don't have access, it will tell you to go and create them. So I'll just pause here for 2 seconds, and you'll see this is the first page of the installer. It has the OpenJDK V8 that'll run on Windows, a Red Hat Container Development Toolkit, which is called CDK. So this is where we have Docker and OpenShift and a base OS to run on your Windows machine. Then Red Hat Developer Studio, in this case it's called version 9. which will have all the Eclipse tooling for doing Java EE, JavaScript development, and now container target development too. And then finally, inside there'll be a Red Hat OpenShift Enterprise. And if I go further, you'll see a little bit of details. It'll start downloading all these things in the background. We also have everything bundled. It'll probably be a bit bigger. But the idea is it will start installing like CDK, Vagrant, VirtualBox, JDK, JBS, and Sequin, as in this case, which is to get stuff like rsync and SSH, which you need to talk from your host, in this case Windows, to Docker and OpenShift in a nice manner. And I'm just gonna fast forward because this will take some time, and there's no fun in doing that live. So once you're at the end and you're running on Windows, you get it in the folder here now called Development Platform. It has everything in it: CDK, Sequin, JDK, Vagrant, and VirtualBox. And we put it there so it doesn't conflict with anything, just something to be able to run on any machine. And the whole idea, as Pete iterated, is that all this is just kind of configured to work together. So the CDK works on its own, but the IDE is set up to be able to know where these components are and talk to them. And that's the installer. I think, yeah. Yes, that's all the list to the installer. And now I'm just gonna drop back and hand it over to Fred, and Fred will continue from the Eclipse side, and then I'll be back in a few seconds. So over to you, Fred. I'll stop sharing my screen, and you should be able to take it.
All right. Can you see anything?
Yes, we can.
Right. So I'm unfortunately not running Windows, but it's pretty much the same thing. Once you're inside JBDS, after the installer completed, the installer will have created something called a CDK server adapter that will be shown in the service view here. So that CDK server adapter basically allows us to start and stop the Vagrant file that starts the CDK itself. So once I start it, what will happen is it will spin up the OpenShift instance, and we'll also be able to show the Docker registry inside the CDK. So let me just start it. So the first thing it asks me is the password for my Red Hat login. So typing it. Okay. And once it's started, I will be able to see the Docker Explorer. In the Docker Explorer view, I can see the CDK server adapter Docker registry that contains some containers running. So this is basically the internals of the OpenShift instance that's running. I can see containers, images, so a lot of things. So the Docker tooling allows me to, from that Docker registry, to pull images if I want. I could search for wildfly images, for instance. Search them. Wild without a typo will be better. There you go. I can select the image, select the tag I want to install, and click finish, and it will pull the image in my Docker registry. So yeah, this is basically the internals of the OpenShift instance that I'm running from the CDK. So on the other side, in the OpenShift Explorer, you will see that I have a new connection to the local OpenShift instance provided by the CDK. So in that instance, I have a couple projects, Take and Tag, and my goal now is to deploy a Java EE app onto OpenShift. So this is my local cloud environment running on my laptop. So in order to do that, what I can do is pick any kind of project from the JBoss Central page, which allows me to access at least, say, 200 examples. So if I want to create a REST application using the JAX-RS framework, I can select, for instance, Hello World RS, and it's loading the metadata. It will take a couple of seconds, and the wizard tells me that this app runs on EAP6 or more, or Wildfly, and it works best using the Maven CDI configurator. So I will not complete the process here because it takes a few seconds, and I already have it in my workspace. So this app is a Java EE app using REST endpoints and CDI as a dependency injection framework. So the tooling that we provide allows you to quickly navigate through the REST endpoints. I can click on the Project Explorer view on these endpoints. I can debug, run them on debug mode on server. For instance, here there's a web service tester provided by JBS. I can click run, or I can test the JSON endpoint, and the response body outputs the results. So this is my Java EE app. Runs locally on my local JBoss instance. So now the goal is to run that same web app inside OpenShift. So how to do that? It's as simple as saying configure deploy to OpenShift. Now, in order to do that, so this is the signing page to OpenShift. You need your username and password. So now, in order to deploy your app, there's one major prerequisite. This project needs to be shared with Git, so that the OpenShift instance knows where the source lives, and so it can clone the repository and build the sources. So I've done that before creating after creating the project before the demo. Now that I have my selected project, because this is a Maven-based project, it has a POM XML. The wizard will filter the available templates on OpenShift using the EAP keyword, but I can select any other kind of template if I want. So in our case, I'm going to just stick with the EAP64 basic S2I template. It's a template that basically runs the same EAP server, but on OpenShift. So here in the template parameters, I can see the source repository URL points at my personal repository on GitHub. I click next, finish, and the application has been created on OpenShift. So in the tag, oops, refresh there. Demo gods, where are you? Okay, so in my tag project, my EAP app is running. The build is running. So what I can do is open the build log, see what's happening, and I can see the Maven app is being built. So it's going to take a long time, about 5 minutes. So in the meantime, we can do some other things probably. We can take a look at what the OpenShift Explorer provides. So we can see we can have access to build logs, but we can also take another app, for instance, that one that's already deployed. and do show in web browser. And in that case, I have a Node.js app that's running on OpenShift on my local machine. I can also show the same project in the web console. So this is the OpenShift console. So if you're familiar with OpenShift, then you will be at ease here. And another thing that we can do is edit some configuration. So in that case, my Node app points at the OpenShift repository. So I want to change that to use my own fork. I can edit the build config and click check the source, change it to my fork, save it, and you will see in the OpenShift Explorer the Git URL change to use my own fork. So I don't have it in my workspace, but I can import that app in my workspace and do import application. It should take a few seconds. There, next. Clone location, finish. And there, I took the sources from the app referenced in my OpenShift app and imported everything in my workspace. So what's the status on my EAP app? Build seems to be complete. Pod is running. Pod log. So the server is started. Started in 70 seconds. So let's see if it's already running. Showing web browser. There it is. Okay, so that's one way to deploy your local project on OpenShift, but it takes several minutes. So the turnaround is not really exciting, but we can do better. So I'm going to demo now how to get incremental deployment in a really, really much faster way using the Node.js app. So what I'm going to do is pretend that I have a local server for Node.js. So I'm going to create a new server. It's an OpenShift 3 server. Next. Still selecting my server, my OpenShift connection. And so I'll select my project. This is the source path of my project. And basically what's going to happen is we're going to do a rsync between the local machine and the remote pod on OpenShift. So my service is Node.js. Click finish. So my server is created. I can show in the web browser. Still running, okay. So let's do some changes here in my index page. Okay, so we're going to change the title. Hello, Perl, and publish. So it's publishing. It's done. And if I refresh it, the app has been refreshed. So it's much, much faster to work that way using the OCR sync feature that's hidden behind that OpenShift server adapter. We can do even slightly better. here I had to refresh the browser manually, but I can also open that page in a live reload server. So basically, the live reload server acts as a proxy to the OpenShift server. So I got the URL here. I got a local URL, and every time my browser receives a query, it will transmit the query to the server on OpenShift. And every time I do a change, every time I publish something on my server, the OpenShift, the live reload server will refresh the web page directly. So let's see how it looks. Now if I publish, there, it's refreshed automatically. So currently we still need to manually do the publishing part, but eventually we'll do the automatic publishing as soon as you save your file. So that's a way to get a much better turnaround while developing your app on OpenShift. So we deployed our EAP app earlier. If we look at the images on the Docker registry, I can refresh them, and you can see the Docker, a Docker image has been added to the Docker registry, matching my EAP app. So that's about it, the current status of the OpenShift Eclipse OpenShift tooling. And back to you, Max.
Thank you. And I'm just trying to find the share screen again. Go. And you should be able to see my screen again. Okay. So what Fred was so good to show was the Eclipse tooling. So I did first the all-in-one installer that again takes all the bits you need for your Windows machine and get it up and running. It saves you time. You don't have to spend time on setting up both Docker, Bacon, the whole shebang. And then when everything is set up, it kind of just works. Not kind of.
Yeah, Max, I can't hear you at the moment.
You cannot hear me. Why can't you hear me?
I can hear you.
Okay. So someone can hear me. Okay, I'll go on then.
Max up.
Okay. I'll continue. So
okay.
Everything just works. The setup, when you start up Eclipse, it will know about the VM you have running. We installed. It will know about the CDK, the Vagrant file that is used for starting it. It will know about the Docker and OpenShift that comes available when CDK starts up, and you don't have to set anything up inside Eclipse. And then, of course, there is the actual container tooling, so which Fred showed, like for Docker and OpenShift, etc. He also showed that we have a bunch of OpenShift-ready quick starts. If you used JBoss Developer Studio in the past or been on developer.jboss.org, you've seen some of these quick starts in the early form, working on both locally and OpenShift v2. These are now being expanded also to cover OpenShift v3. Beyond that, he showed to take one of these quick starts and load into Eclipse, meaning it was an existing Eclipse product that was not an OpenShift, but then take that existing product and deploy up to an OpenShift instance. Now, in this case, running locally on your CDK. If you know OC, the command line, this is similar to what OC New App does, but just in an Eclipse setting. But now where it becomes really interesting is the incremental deployment. So what he did show, what we have working now, is incremental deployment of Node.js. Because as you noticed, the first deploy of the Java EE app might be a bit heavy, especially if you are doing the full Maven build, the full Docker, etc. But so we wanted to spend some time on making the deployment of Delta changes efficient. So in OpenShift, there's a tool called OC Sync, which allows you to incrementally take changes from your local file system up to an OpenShift instance. And what Fred showed was using that behind the scenes in our server adapter to do it for a Node app. And then together with the Node app, he had live reload running. So when he did changes in his IDE, they reloaded in his browser once they had published to the server. And if you come from a local deployment, you go like, why is this interesting? Like we've been doing this for a while. But that's exactly what we're trying to do. Make sure that what you've been able to do locally, that you can do that on an OpenShift instance, whether that is the CDK locally here, which the turnaround should be decent, or if it's in a cloud where it might be a bit slower because of network latency, etc. But anyway, the idea is that local OpenShift deployment you have, you get almost instant feedback, similar to what you have for local deployment via this incremental deployment using OC Sync. And then the live reload that we've had for a while, but it's all integrated now in the IDE tooling and in OpenShift. Okay, so a few things that we didn't manage to show you here, but we are either already have but couldn't fit into a demo or be planning. So one is the incremental deployment of Java EE. So again, we saw the rather slow first deployment of Java EE. We want to do the same thing using a local build and an OC Sync over, so we can do the Java class replacement, HTML, CSS, JavaScript, etc. replacement. But on top of that, if you know Java, sometimes we change classes. These changes doesn't take effect immediately. This is something that when we run locally, we can just kind of restart the container and everything is fine. Restart the application container. But in a Docker scenario or in a microservice scenario, this might actually take longer for some cases. So we've looked at integrating what we call hot reload of Java apps. So if you know things like Spring Reloaded or JRebel, that kind of functionality, we are looking at embedding into the toolset, into OpenShift, with a few things that is optimized for EAP. So you get the right, you only get restarted the things you actually need. And again, this is all to make sure that when you change something in your development environment, you can see the change fast without having to wait for too many redeployments. Another thing is when you have Docker images, you might have your own Docker image you have running locally, or you have it on Docker Hub. You can also take these Docker images and deploy to OpenShift from the tooling. Even more is one of the things that the thing we don't have yet, but really wanted to do is when you have this local setup in an OpenShift application running locally, how do I make that run on another OpenShift instance? But luckily, because we're using Kubernetes, this should just be about taking your application and the scriptures from Kubernetes and deploy it to another instance. So you want to make that easy too. Oh, and I skipped one. Sorry for that. Another one we have is Java and Node.js debugging. We have already today, you can port forward to, so when you're running in a Docker container or OpenShift, there will be stuff that is, shielded off for your local environment. We've made so our containers can be run with a certain flag, so they enable debugging, and then that the tooling can connect to it, or any other Java debugger for that matter, can connect to it, and you can use a debugger as you used to. But we're also doing it for Node.js. And today, if you're running Node.js on OpenShift, it will run, let's call it in production mode, meaning you'll have to restart the full container to see changes to your JavaScript. But you can do changes to HTML and CSS just fine, but not for the JavaScript code, which is kind of, the thing we want to change when you do Node.js. So we've extended the Node.js containers on OpenShift to have, again, a similar flag we can set. So when you run the Node application, the IDE can do OC Sync. It will see a change, and it will restart the Node.js container, not the whole setup, meaning you won't lose, you don't have to wait for anything there on the OpenShift side. Okay, so that's kind of the additional plant features. Another one is, we focus very much on Eclipse in this presentation. What if you don't use Eclipse? Well, the great thing is that all the tooling we actually showed Eclipse didn't use anything, custom or specific. It was all using standard Docker protocols, OpenShift APIs, etc. And that means existing tooling out there, whether that is, Docker command line, OpenShift command line, OC, kube control, all that stuff, you can run on your Windows instance and connect to the CDK. There is a Vagrant plugin called Vagrant ADB Info, which will dump out the information that is necessary to set up these command line tools. So if you tried things like Docker Machine or Vagrant in a box, that this works in the same way. You just get these environment variables, which then other tools can use and connect to. So if you are a non-Eclipse user, or a command line user, or IntelliJ, or something else, and they have similar tooling, this will work with it too. And finally, the CDK is basically a little pre-configured Linux VM, meaning you can do Vagrant SSH into it, and then you can, access it as you want as in a Linux mindset, if you want that for you. Okay, so how to try this out now? As Pete said in the beginning, this is kind of alpha quality. There are some parts that is there now, especially the Eclipse tooling that Fred was showing. This is all something you can try today. Use that against existing Docker, existing OpenShift instances. The part that is not in a easy to download, available today thing is the CDK packaged in a way that has OpenShift in it. But you can get the source for it. It's all on github.com, Red Hat-tooling OpenShift Vagrant, as is on the slide. And then finally, the whole installer, also the source code for that is available. It's actually an Electron app if you are interested in that kind of thing. I just want to point out that currently the downside of these builds is they depend on binaries only available inside Red Hat right now, but it can give you an idea of what you're working on, and we will update these repos. And this is actually our master repos, so you can see what we're working on and give feedback once these things come out. Okay, and that actually brings us to the end. Not sure if Pete have any final comments.
No, I don't have any comments. I just want to say thank you very much to both Max and Fred for a really good demo. That was really informative for me, definitely. So I really enjoyed that. Thank you very much.
It was definitely informative, and it really, you guys have made a lot of progress since the last time I saw this, probably November last year. So it looks really very interesting. If people want to give feedback, what's the best method for them to do that?
Sorry, I was on mute. So we have on the slide, there's a JBoss Developer Studio forum. You can post questions there. And otherwise on Twitter, we are on JBoss Tools, and we also listen to questions on at OpenShift.
Okay. So you pretty much, one of the questions I was going to ask you was what are the new features that are coming, and I think you covered that off in the last couple of slides, so thank you for that. There was an earlier question by Marcus, but I think you also, I'm going to unmute him, and around the dependency on GitHub, but I think we covered that off as well.
I saw a question about why we don't allow the product to be mounted from your host, the laptop workspace, into your OpenShift container, so you don't have to commit to the Git repo and redeploy every time. Yeah. So this is actually, I can answer that in a bit more detail than I did on the chat. So basically, there's two parts here. One is what you suggest there, Marcus, is perfectly doable, especially in a Docker world where the Docker is running in on your machine. You can do what's called a mounted volume. The downside currently is that if you're running on Windows, doing mounted shared volumes is actually not very fast, and there's some tricks to it. But you can actually do it. If I can maybe add a few comments to the slides, some blogs we did 6 to 8 months ago about how to actually do that from the tooling today. So you can do that in a Docker scenario. When you do go to OpenShift, we'll be actually running in a cloud where there's a cloud-like environment. There'll be multiple pods that might need to be synchronized to. It's not just a single place. There is network stuff that might not be easily available for us. And that's why, as Fred showed and I talked about, we use this thing called OC Sync, which will basically it'll use our sync behind the scenes to take an efficient delta and copy over to the container. And that basically does the same trick. So you don't have to do the git commit, etc. So I hope that answers the question that why we doing more than just mounting the volume.
I'll also add that maybe from a kind of a higher level perspective, I think so the problem that we're talking about here, right, is how do we get the files from the person's local workspace into the application, right? That's the kind of the fundamental problem we're trying to solve, and how do we do that quickly? And I think we recognize that is a real problem that definitely needs solving. That was a part of the original brief for this initiative that we've been working on here. It's still something I think that we need to address better, whether it's done best by mounting volumes or by running, a Git server locally that people can, push and pull from. I think there's multiple ways to solve that problem of how do you get files from the workstation and up into OpenShift. I think, both, we and the OpenShift team all recognize that this needs to be much easier than it is today. It needs to be sort of pretty much transparent and quick. But I don't think we've really focused or fixed on a particular solution today. I think there's a variety of solutions that we could look at.
There is one last question here. Peter Larson is asking, is Tomcat supported as well?
So the stuff we've shown works too on a Tomcat setup. So this will work with the Tomcat Tomcat OpenShift supported image.
Perfect. All right.
So let me, again, just come in briefly on that to explain our philosophy. And I talked a little bit about this at the beginning, but our philosophy is kind of, we optimize for certain scenarios, we support certain scenarios as a company, as Red Hat supports certain scenarios, right? And then there are other scenarios that are possible. So for us, kind of that EAP path and the Node.js path that Max and Fred showed, that's kind of our optimal path. That's the one we're really focused on, kind of laser focused on. There are others that we definitely support, such as the Tomcat one that was just mentioned. Is that the one that we spend most of our time, and we really push the QE team to make sure they're really doing a great job of testing that? Is that the one we show in demos? Is that the one we, document the hell out of? No, but it should still work. It does still work, and we still support it. And then there's things that are possible, right? So things that should work, and maybe you have to do a little bit of fiddling to get them going, but, they should work in there. So, I think from my perspective, it helps to sort of always keep that philosophy in mind. And that explains why we always show particular paths through the tools.
And we've got another couple of questions. Ramon is asking, how about monitoring with JMX in the container? Any way to connect mission control or something similar to the pod?
So I can answer that. So the simple answer is yes, you can do that. It currently requires you basically just have to have port forwarding. It requires two parts. You have to port forward to the container, and the container has to expose that port. So you can do it manually today. We actually have kind of mission control like features in JBoss tools that I would like to enable in this fashion. But currently it's a manual process, but you can do it. I hope we can find a way with, I talked with the OpenShift team that we can actually, because we're running in a local environment, we can do a bit more tricks than in a full-blown OpenShift. So we can basically do what's called a Docker exec behind the scenes to open up these ports. But this is just kind of ideas. But technically it is possible, but right now it's a manual process.
There was one last question. How much resources are used by the CDK VM, CPU, and RAM? And Brian.
So I think Brian answered. I think even the one we're using right now, we're actually using less. It's like 1.5 gig we've set up, and 2 CPUs. But yeah, we have a default right now. We haven't tuned it, but yeah, it'll be somewhere between 1 or 2 or 3. But the idea is we'll have a default, and you can override it if you want to, depending on your experience, what kind of large application you want to deploy.
Let's see. Give it a minute or two. That was almost a full. Any template tooling on scope?
Any template to I don't understand the question, that one.
So Ramon, you want to clarify that? I think he's referring to Kubernetes OS.
For building a template. Okay. So we don't have specifically like template tool, like advanced tooling plan in this area. But what we have recognized is we're gonna add. We are working on adding a JSON editor to the Eclipse base, which allows us to have content assist and basic validation based on JSON schema. That alone will become a bit nicer to edit. If you notice the editor that when Fred was editing the config, that was actually a syntax highlighted editor. So that's kind of the precursor of this JSON editor. But the fact we can add the JSON schema to it means stuff like content assist becomes better. And we are working on making that extendable so we can add like OpenShift specific logic to aid the user there. But that's about it at the moment. But yeah, it's something we discussed, but nothing specific beyond what I just mentioned.
Okay, and the one thing that everybody always asks for, do you have a roadmap, what is available today and 6 months and later? And I had also asked earlier if there's a Trello card tracking some of these things that you could share.
Yes, so there is a Trello card. Pete will add it to at the end of slides here. More specific roadmaps. Right now it's a bit spread out. I'm not sure if Pete knows anything, but right now it's spread out between JBDS and the CDK area. But yeah, you have the Trello. Yeah.
Yeah, we don't have. So we're still, as you can see, working on getting this right. I don't have a sort of dates that we can give at the moment, unfortunately. That's one of the things we need to work on, is a set of dates. But this is, as you saw, this is made up of a number of different components. Quite a few of those components are, released reasonably frequently. So things like the JBDS support. I mean, Max, you can definitely talk about when the JBDS support for some of the features that we saw today would be going GA. As for the CDK GA release date, we don't have that immediately available at the moment. And I believe the OC Sync support is in OpenShift 3.1.
Yep.
Yeah, correct. So yeah, the GA of the tooling we showed today will be in March. That's the plan, and then we will start doing more over the summer. And yeah, those dates and times are in our JBDS Jira. You can set links for that.
Right.
And there was a question about, do you have integrated VirtualBox into your solution? What about other virtualization tech like VMware? So this is a fun one, in the sense that we had to take a pick of which one we want to put in there. And right now, VirtualBox was the one because it ran on it was the easiest to get going with for us and having in distribution. And I think the CDK itself supports VirtualBox and one more, but yeah, Brian says libvirt, and others are on the horizon. For this scenario here, I think if there's one we would target after this, it might be hypervisor for Windows, because if you run the people who are running Windows that has hypervisor can actually not run VirtualBox. So that's the fun of that. So the answer is right now we are doing VirtualBox, but we will probably do something more in the future. Which ones is undecided.
I'll add to that what we showed you today was kind of, we focused on that what we think of as the main path through the installer, which is getting all of the core tools installed for someone who doesn't have them already. One of the enhancements we need to do as we go through the beta phase is adding the ability to select existing components that you might already have on the system, and also allowing people to use things like other hypervisors. So the CDK supports a number of different virtual machines. So we want to be able to make sure that we can allow that to be selected during the install process. If you already have them installed, I think that would be the key thing, right? If you're using our single download, single installer, the one we're going to be able to install for you would be VirtualBox or possibly Hyper-V in the future, or use Hyper-V in the future. If you've got other ones already installed, we need to be able to, as a feature request for the installer, we need to be able to make sure that you can select the one that you want to use.
Yeah.
So Pete and everybody else, thank you very much for today. If people from the community want to get involved in helping testing or adding new features, what's the best way for them to do that?
So I would suggest going to the GitHub repositories that we have linked from the slides. We're pretty active in the issue tracker there, so there are often long discussions on the issue tracker. We have quite a few contributors from Red Hat who jump in and help out with getting things done there. So that's a great way to follow along, I think, on both of those GitHub repositories that Max linked, following the pull requests, following the issues. That's probably the best way to get involved today.
Awesome. So,
and otherwise, we also in all the regular RSC rooms on Freenode, like OpenShift, that kind of thing.
Yeah, OpenShift and OpenShift-dev are very good places to ask questions and to give suggestions. So, but tracking them through the issues is pretty cool. And Ryan's just said for the CDK on Freenode, join Atomic and I'm going to say it wrong, Nucleol. Nucleol there. So yeah, there's lots of places there, and we can all help you get to the right funnel to get the feedback in. So thank you very much to everybody for coming today. I look forward to when you go GA and have some more new features to showcasing it again. And again, thank you, Peter, for joining us from that hotel room wherever you are. And everybody else who's joined. It was very enlightening, and I'm looking forward to being able to demo this myself next time. All right, take care. And the recording will be up. Next week's session will be on an Atomic and OpenShift update with Mike McGrath and members of the product management team from OpenShift. So that should be fun too, so stay tuned.
Thank you.